Okay, so the first half of calculus is all about the derivative, if you haven't figured that out by now. The second half is going to be all about the antiderivative. So if you are given, let's say f prime of x, so the derivative is 2x, are you able to find out what the original is? So if the derivative is 2x, what is my original? Anybody know it?
X squared.
Good, x squared. Now is that the only original function whose derivative is 2x? Can somebody think of a different one that is the same derivative 2x?
X squared plus 1.
Excellent. X squared plus 1. X squared plus 2. X squared minus 5. So that's why when we do an antiderivative, we just attach a plus c. So this is the general form of the antiderivative of 2x. It's going to be x squared plus c. So let's try another one. If I have f prime of x, and let's say it's 6. See if you can figure out what f of x would be. Well, hopefully it shouldn't take too much thought. It'd be 6x plus c. How about see if you can figure that one out. Anybody get it? You know you got it.
5x squared.
Good, Jamin. Yeah, 5x squared. Yeah, plus c. So 5x, so you can always just find the derivative real quick and confirm 5x squared plus c. Okay, so those are all antiderivatives. We're going to spend, maybe we'll do one more hard one. How about 6x squared plus 2? I'll give you a minute to try that. And they will get more and more difficult as the course moves on. What do we get? Well, we know it's going to be x cubed. And if I bring down the 3, that's not quite 6. So if I put a 2 there, find the derivative of that, it will be 6x squared. So plus 2x plus c. So we'll do more and more of those as the course goes on. I mean, we could eventually, this is going to lead to something called an integral, and that's what starting chapter 5, the rest of the course all has integrals in it. Alright, so I'm going to propose a question. It seems like a pretty straightforward one, or it's a very simple question. Doesn't mean it's easy to figure out, but let's say we've got a partridge or grouse, and we shoot the partridge. Sorry if that offends somebody. We shoot it with a rubber band and just temporarily knock it unconscious, but then it lives. But it does fall to the ground. So shoot the partridge, and let's say it's 8 meters up in the tree, in the pear tree. My question is, how fast is it traveling when it hits the ground? So we're assuming that there's no air resistance, and you could probably, some people here may be in physics, so you may know a formula to figure this out, but you don't need a formula. You just need to know calculus. But one thing you do need to know is the gravitational pull of the Earth in meters per second squared. What is that? Anybody know it?
9.8, or you can just round to 10.
Good. Well, we'll go 9.8. So gravity is the acceleration, and gravity is, so it's negative because it's going down, meters per second squared. So if you know that, see if you can figure out how fast it's traveling when it hits the ground.
For the time.
So you're thinking 1.278, is that what you said?
Yeah, for seconds.
And that's how long it takes to hit the ground?
Yeah.
Okay, so you have one more step, right?
We got that time, and then we got 12.5146 meters per second.
Okay.
Yeah, we're directed downward.
Okay. Good. We'll see how we do here. So acceleration is negative 9.8. Can find the antiderivative, find the velocity right here, plus c. I need an initial value to find c. Well, I know that when time is 0, the velocity is 0, because the Partridge is just sitting there. It's not flying up or down. So its initial vertical velocity is 0. Plug 0 in for t, 0 in for v. Solve for c, so c is 0. So that's my velocity equation. We also need to know the position or height equation, so another antiderivative. We need an initial value to find out what c is. We know that when time is 0, that its position is 8 meters up. So you can plug 0 in for time, 8 in for the position, and we get c is 8, so that's my position equation.
Mr. Winkler,
Yeah.
are you supposed to be presenting?
Am I not? It stops me from. Oh, jeez. Yeah. Again. It when I go from the room to the other room, it shuts off the presentation, I guess. Thanks. I was following along with my fingers again. Okay. So there's my position equation. We want to know how fast it's traveling when it hits the ground. So what do we know about the ground? What do we know is true at the ground? What do we know about the height or the velocity or the acceleration of the ground?
It's all 0.
So what's 0? Not the height is 0, right? Ground level height is 0. So we can find this is 0. We can do some algebra to figure out when it hits the ground. So t squared equals 8 over 4.9 square root, and you're telling me it's 1.27 or something? Seconds. I'll take your word for it. And then we want to know the velocity, how fast it travels when it hits the ground. We would find v, is it 1.27? I'm just going by memory. So what did you say, Noah? You got negative 12 something?
Actually, I didn't plug it into the calculator. I did, so
Okay, Carter, what'd you get?
yeah, negative 12.51.
Okay. Seems like and this was 1.27?
Yeah.
Okay. So that would be meters per second is our velocity. Seems like a reasonable rate. The bird isn't traveling 1 million meters per second. It's not traveling 1 meter per second. So seems like a reasonable answer. All right, I'm going to stop.